Hi, I'm Larry Nelson, an instrument-rated private pilot with a passion for aviation. I built what I think is the perfect aircraft for my mission, exploring my home state of Arizona and beyond while taking you along for the ride. I also want to showcase affordable aviation and show the incredible capability of these light airplanes. Follow me along in my aviation journey. This is Zenvair Pilot. So you guys have asked for it, and here it is. I sat down with John from GRT Avionics to give a rundown of the issues that we see and that we've helped people with on their installations of GRT Avionics. Pilot, I'm joined today by GRT Avionics. Let's just call you the extraordinaire, the person that everybody talks to on the phone first. This is John. And for those of you guys who are doing an installation, you're definitely going to spend a lot of time talking to John. But as we were talking, there's definitely 5 things that a lot of guys have issues with. And so we thought we would get together and share kind of our thoughts on those top 5 concerns. So that's why we're talking about the top 5 concerns for your GRT installation. Now, John, correct me if I'm wrong, most of these things we're going to talk about would not only be valid for GRT avionics, but just any glass panel installation, to get just any glass panel installation.
I'd say, yeah, these are sort of more common problems that are not specific to us. Not even problems, but just considerations.
Consideration, that's a good way to put it. So let's talk about the first one. So me and you have talked to a lot of people, and again, commenting on my channel, calling you guys. I would say that probably the number one thing is people trying to figure out how to configure their serial ports or their aux ports, or selecting them even. So how would you suggest that somebody go about doing that within their own installation?
Well, so the tricky thing is that some people assume that certain serial ports or aux ports are used for certain things, and the reality is they're all equally configurable, which can lead to sort of a decision paralysis if you don't really have a good idea of what you want to hook up where. So I usually recommend just sit down with just like a paper wire diagram and say, okay, port 1, I'm going to use that for engine monitor. Port 2, I'm going to put my autopilot servos on that one, and just so on and so forth. That way, when it comes to time to actually do the wiring, you just basically follow a checklist and not have to think about anything.
Yeah, I'd say I think one of the big things I've noticed is people letting configuration management or scope creep kind of come in after the fact. Yeah. So somebody will be like, yeah, I'm going to put in autopilot. Oh, well, now I'm going to put in this, and now I'm going to put in that, and all of a sudden they're running out of serial ports.
Yeah.
So here's the other thing is if, like, for example, a lot of guys who are doing this are going to have both let's just say a Sport EX and an EIS. Can those serial ports be shared across those pieces of equipment?
So the serial ports can be unique to each EFIS, but the 2 EFISs can be linked to talk to each other.
Okay. And so when we link them, the data that we're sending to one is obviously shared with the other one, correct?
Yes, and you can configure what data you would like to be sent across that link, so you can customize what's being sent back and forth, and you can actually go as far as customizing which screen you want to be the primary and which one to be the secondary, so one screen is exclusively talking to the other one and not listening.
Now, there's some things that we wouldn't want to share. Like, for example, I know that when we were talking about my installation, because I definitely was running short on serial ports, we wouldn't want to be sending, for example, RINC data or data from like going after the autopilot through the EIS, for example, as opposed to just keeping that within the Sport EFIS itself.
Right. Well, and actually, the aux ports on the EIS are more limited in their scope and scale. So the aux ports in the EIS typically are just going to be like pressure sensors or temperature sensors, things like that. But yes, there are certain things that are high data transfer rates that you want to have not run through anything except like just connected to the screen directly, I guess is the best way to say that.
Okay. Now within the aux ports, one of the things that I've had a lot of people reach out to me are things like scale factor. So what is scale factor, and how is that important to me as somebody installing one of these systems?
The sort of simplest explanation, the scale factor and offset of an aux port on an EIS essentially tells the EIS how to properly interpret the data it's seeing from the sensor. So all of the sensors we use are resistance-based, and based off of the scale factor and offset, it'll say, okay, this data is coming from a fuel pressure sensor or a current sensor or something like that. It basically just essentially translates the data into a usable format. So some things on the EIS, like oil pressure, oil temperature, are what we refer to as dedicated inputs, meaning that they're always going to be that one thing, and it's looking for a specific sensor because we've already gone in and done the calibration for that sensor. And typically, those are things that are more flight critical. You'd say, you want to make sure that you don't want there to be a chance you could have incorrectly configured your oil pressure sensor, because that one's pretty important.
Yeah. Now, I think what a lot of people don't realize is when you're talking about the EIS or we're talking about the aux ports, it's almost like using a multimeter. So where it's reading
Very
a
much
signal.
so. Very much so.
And so what we're trying to do there is get the scale and the factors, everything, so that we have a range that when we tell the system this is the top and this is the bottom, it can figure out the scale and the offsets to say what's 0 and what's 100%.
Exactly. Yep.
Okay. So again, just trying to get people to understand that what's kind of involved in that, because it's not as simple as, what is a scale factor? It's like, well, it's like using a multimeter.
You're right. Yes.
Okay. Now with that, a lot of other people have talked to me about or want to know more about the excitation wiring. So what is that wire and what is it kind of doing?
Essentially, it's giving a voltage signal that is being used to sort of bounce back and forth between the sending unit and the EIS, and then there'll be a specific resistor in there. So we have known values of, okay, if you're using the low pressure sensor for fuel, they say, okay, install this resistor on there, and we have a known quantity. If you've installed that resistor, we're getting 5 volts, so we can interpret the resistance range of the sensor based off of that, and that's how we get our signal on the EIS.
And I think a lot of people kind of mistake this. Like, for example, if you were to use like a VDO, say fuel sender or fuel gauge, it has that internally wired to it. It's already doing that. It's just that because you guys are using aux ports for a lot of different things, you can't just send out a random 5-volt signal.
Right.
Okay. So again, I think those are the first two things we're talking about is, first the aux ports, serial ports, and then that excitation wiring. So, those are two things I've heard a lot of questions about.
Sure.
But again, that excitation wire goes into calibration of the fuel tanks and how much fuel's in there. And like I said, we've talked about this before. There's two really different ways of doing it. Can you give us an explanation of those two ways to calibrate your fuel senders?
Yeah, so one is going to be done on the EIS itself, and one is going to be done using the EFIS more specifically. The one with the EIS, basically, you'll set the scale factor to 100 and the offset to 0. And then on your EIS, whatever aux port you've used, for argument's sake, let's say aux 1, with an empty tank, you'll have a random reading. It won't make any, it's not going to correlate to anything. And then you'll start adding fuel slowly. And what happens is after you get to enough fuel for the probe to actually register it, because there's always going to be a little bit at the top and bottom that the probe can't quite see, that number will start to. Yeah.
So before you go too much farther, I think a lot of people don't understand the why. So why is it that we have a little bit of fuel at the bottom and a little bit of fuel at the top with a float sensor? Then we're not saying like for example, I've got 10-gallon tanks, and mine doesn't start seeing a decrease until 8, and then it kind of cuts off at about 1.5. So why is
so that? Essentially the little cork or the floater will get hit the top of the tank when there's still an amount of like open air in there. And the same thing on the bottom, it'll rest on the bottom of the fuel tank when there's still an amount of fuel left in there.
Okay, and that goes into, you need to understand where those 2 points are. So for us with these sensors, where your unusable fuel level is, but also where I have no more sensing of fuel.
Exactly. Yep. So, for example, in your case, the EIS effectively is going to interpret that as an 8-gallon tank because it can't use, the top and bottom of it.
Yeah.
So basically what we're doing is we're finding the empty value and the full value, or measurable empty and measurable full value. So you'll start adding fuel to the tank, and that number will start to change. It'll start going up. And you keep adding fuel until the number stops going up, and then you write down the empty value and the full value. And then you also take the amount of fuel you added in between those 2 points. So not in the tank itself, but when the number started to move, indicating measurable fuel, and when the number stopped moving, indicating the end of measurable fuel. And then there's an equation you can do. We have a calculator on our website. I don't know why I pointed like you. That you can plug all those numbers into. It'll give you a scale factor and offset to then change that serial port to. That's one way of doing it. Just have an EIS, or if you want to calibrate the fuel on the EIS specifically. There's also a fuel entry table on the EFIS that functions differently in that you basically will add like a set amount of fuel. It doesn't matter what it is, but it has to be even the same increment each time, right? So added 2 gallons, this is what it says. Added 2 gallons, this is what it says, and so on and so forth until the tank's full. And that's the other way of calibrating that.
Yeah, and I'll tell you, when I did that on mine, it was really important to have 2 people there, especially when you get to the bottom and the top, because what will happen is, like for example, on one of mine, it cut off at like 7.8 gallons, and so I could have gone to 7, to 8 gallons. Go, oh, I've got a number, and I start putting in more fuel, and it doesn't change. So you kind of need to know where that resistance value changes as you're doing it that method.
Yep.
Okay. So again, important things to know, and I think a lot of people, this is kind of one of those last minute things you're doing at the end, and it's good to kind of hear how the 2 different methods are to do that.
Yep.
Now, I'm guessing another thing you guys hear a lot about are routing, wiring, the grounds, how important those are. Do we need shielded wire? So give us a rundown on what are some of the considerations for how we're routing wiring to the EIS and EFIS.
It depends on the engine installation, but sometimes you can run wires too close to like ignition coils or other things in the engine that will generate interference. It's best to, if you're experiencing that, try to move the wires away. But there's also like ferrite filters you can use to help counteract that. As far as the actual grounds are concerned, I mean, ideally ground is 0 volts. That's ideally what ground is. But unfortunately, it's not quite a binary thing. So if you have your EIS ground in one location, and then you ground a probe at a different location that doesn't share that ground, there's a chance that they're not both going to be 0 volts. It might be, a very small amount of voltage, but it's enough to throw off the reading because ground is being used as the base point for it. Like this is what everything considers 0 volts.
So for example, let's say that, like a lot of guys, we're going to say, well, I can put a ground right here and it's like 2 inches away from the panel, but I may have grounds in another location in the plane, and there could be a differential between those 2 grounds.
Exactly. Yep. That is exactly right. So that's why we recommend the probes and the EIS should share a common ground.
Okay.
So you'll hear the term common ground thrown around quite a lot, and that's what it means, is that everything is connected to the same ground. And ideally, ideally in an installation, common ground would basically be any part of the airframe. But that's not always the case, and so that can be a common pitfall, is that everything looks right, you're getting a weird reading and saying, oh, the ground looks like it's connected correctly, and it's because it is, it's just that the grounds aren't common, and there's a differential between them.
And I think this goes back to our earlier statement that when you're talking about the EIS and the aux ports, at the end of the day, it's basically just a very calibrated, multimeter. And so
a very specifically purposed multimeter. Yeah, exactly.
And so, yeah, if you're having a ground that's slightly different, it's going to throw readings different than you expect to receive. Now, what are you guys' thoughts on shielded wire versus just non-shielded wire for the installations?
In our experience, that hasn't really made a ton of difference. I mean, sometimes it can, but by and large, if you're in a place where shielded wire would help, usually it means that you should try to install that differently, because you shouldn't need shielded wire what's the word I'm looking for? Interference.
Yeah, interference.
Yeah.
Yeah, like I said, I think on mine, like for example, I don't think I have any shielded wire anywhere in my installation except for headset jacks and things like that. For the radios, just because I don't want to have that interference in there. But that's a different application than what we're talking about.
I mean, I would, if I had to guess, and probably 95% of people do not bother with shielded wire. Or I guess to say it differently, you only hear about things when they don't work. So the fact that I haven't heard anything about the need for shielded wire tells me that's fine.
Okay. Now, speaking about wiring, how many people have issues with pin termination? For example, putting in those Molex type cramps, making sure they're seated correctly. How much of that plays an issue in the calls that you get every day?
It's just quite important. It's quite important. A pin can be crimped onto a wire, and it can look like it has good crimp, but all those wires are stranded wires, so it's not just one solid piece of copper. It's many little pieces of copper, which makes the wire more flexible and less likely to break. But it can also result in it's harder to get a good crimp going. And so getting good crimpers that are specific for the pins you're using is the thing we highly recommend, because I would say 95% of cases of two things not talking is almost always a connectivity issue between the two of them, and it's almost always when one pin got crimped on the one end of it. Because if you think about it differently, crimping a pin onto a wire is just inherently damaging the wire, but for a useful purpose. So most times, if someone has a connectivity issue, I basically just recommend, hey, chop off the end of that wire, strip it, recrimp it. That'll probably fix the issue.
Now, here's a question. Back to that. Do you guys see any big difference between guys that want to use, like the Garmin type D sub, pins versus like the Molex type crimp pins?
I can't say that I have a ton of additional knowledge about that. I mean, we just use standard crimp D sub pins.
Yeah, there's definitely a cost difference between the two.
Yeah. I really don't see that playing much of a factor in that situation.
All right. Now, one thing that me and you have talked about a lot, and anytime I've had an issue and you guys want to investigate it, recording demos, and I think that's something that's unique to GRT. So, first, I guess, how do you record the demo, and how is that useful to you when you're helping us troubleshoot?
Recording demos is a feature that is pretty handy for helping us troubleshoot, and honestly, just for monitoring engine health or how flights went. There are two ways of doing it. One, you can manually activate the demo recording by, depending on the screen, you either push the far right next button or the more button, and you'll do that, and you'll eventually see a word, the word demo above one of the buttons with a couple of options beneath it, one of which will say record. If you push that button, there's a little selection rectangle that you can move, and you hit it, basically move it down to record, and then just let the buttons time out, or you can manually accept it. And from there, the unit will start recording a demo, which the demo is essentially the unit's recording everything about itself, no matter what page you're on. So you can keep flying like normal, and that unit is going to record everything about itself during the time the demo is running. There's also a way in the settings menu where you can go to settings menu, general setup, and then at the very bottom of that menu, there's an option for demo where you can then set up parameters for auto start stop above or below certain RPMs, or if you have or don't have oil pressure. There's plenty of ways to auto start stop stuff, and you can even get as far as every 5 minutes, 10 minutes, every increment of time, cut and start a new one, so you can get more specific like chunks of information. And the main thing that helps with us in troubleshooting is that one of the biggest problems with troubleshooting is that I can only see what you tell me. And so a lot of the time when I'm asking questions, I'm trying to build myself a picture, a roadmap of what's happening and why it's happening. But if you can record a demo and then email us that information, we have test beds here. I keep pointing at stuff that you can't see.
Yeah.
That we can plug those demo files into, and it actually will show exactly what is happening on your screen at any given time. And a lot of the times, if you're having intermittent issues that, send it back to us, we look at it and we can't get it to show up. If we have a demo of it, we can say, oh, look, that's happening there. And there's a lot of troubleshooting we can do by sort of going into the back end of things and looking at raw data and saying, oh, looks like the roll gyro's, failing. We have to replace that specific thing.
Yeah, I think me and you had one where the answer was that where my 5-volt excitation was too close to the wiring, and every now and then we get this peak of voltage coming through.
That's right. I remember that. Yeah.
Yeah, so we ended up having to do, like you said, one of those ferrite rings and completely solve the problem. But I would explain to you guys, and you just say that makes no sense. That makes no sense. I sent you guys the demo, and you're like, oh, there it is. And so something as simple as the demo saved shipping back and forth, troubleshooting, and actually did. I think at the end of the day, I think it was like a $5 solution to a very frustrating problem.
Yeah.
Okay, and I think this is the last thing we had here on that top 5 thing, which was the settings on the serial ports and how important they are. So, and then the other thing is, using the serial ports, can you do gray code, or can you use that to send in a altitude source to a transponder?
Yes to everything you just said. In the case of like gray code, you'd have to get an adapter because it's not something that's commonly used. So we don't have dedicated gray code lines anymore, but we still have adapters for them. The serial ports, configuring them is it can seem like a daunting task, and it's a little bit of button pushing and knob turning. But if you have that roadmap that I talked about earlier, you can say, okay, I know exactly what is wired where, and you can go in and in any given serial port, you're going to have three settings, four technically, but one of them you can't interface with. The first one is the baud rate. The second one is the input, then the output, and then the input counter. So the baud rate is going to be specific to whatever device is being connected to it. So, for example, an EIS uses 9600 as its baud rate. An ADSB receiver would be 115.200 for its baud rate.
And I think maybe kind of stepping back as older guys like us, we remember those baud modems,
Yep.
and you wanted that 5600 baud modem because that was the fastest modem you could get. So when we're talking about baud rate, that's how fast we're communicating data back and forth. Maybe that's a better way to explain it.
That is the actual way, explanation for it. But then the input and the output basically is just, if you have something hooked up to the input, you have a series of selections that you go through with the knob and you set it for what it is. A lot of things like autopilot servos or transponders or other things like that will take up both. There'll be input and output. But some things like the engine monitor, if you have the one that has a panel face on it anyways, only talk to the EFIS. They don't listen to anything the EFIS says, so it only takes up the input on a serial port. And so things like if you had, this is less common now that ADSB is a thing, but if you had like a transponder that you wanted to have us act as an encoder for, all we do is talk to that transponder. We don't listen to anything it has to say. So what would commonly be done is you'd have the EIS and the outstream encoder on the same serial port because they both use the baud rate of 9600, and it would just be a way to sort of save serial ports.
So as an example, like for on my setup, I'm using a Garmin 327. And what I did was I actually have that setup where I took one output and it's going to my 327. You go in the 327, you say, yep, use this serial port. And now I don't have to have that bundle of wiring. And then when I do my 24-month, and they're checking the pedostatic system, they're able to calibrate the transponder all at the same time. So it actually is kind of a neat little way you guys have done that.
Yeah, it was. Greg's a genius, so he got a lot of these ideas and executed on them very well.
Yeah. All right.
Oh, the one thing I will say is that things that have a higher data transfer rate, or that you want things like autopilot or ADSB in, you want that to be connected directly to the glass panel. Sometimes you can find serial port expanders or things that give you more ports. And anything that has that higher data transfer rate that might cause a slowdown if you have multiple things in between, you want that just to eliminate anything in between, have it go directly to the EFIS.
Okay. So I think, just me and you talking, this kind of hits that top five. Were there any other issues that you could think of that people may want to take a little deeper dive at before they really, as they're having issues? What are some of the other things that you're seeing?
Well, I mean, I have a little scribbled list here, and you basically covered everything on it.
Excellent.
Yeah, I mean the demos, application, fuel level. You basically covered all of them. I mean, there's some other things that, like, building a flight plan can seem daunting or confusing to people, but that's something
which
that
I just put out a video about.
Yes, excellent video.
Yeah.
But it's something that I think having a visual thing to go with it actually makes it make a lot more sense rather than having two dudes talk about it.
Yeah, exactly. All right. So GRT, give us in the last couple of minutes here, tell us a little bit about the company, where you guys are at, and what do you kind of see in the next couple of years for GRT?
Well, where we're at is Grand Rapids, hence the GR of the GRT. Next couple of years, I mean, we're looking to put out a couple of new products here and there. I'm not authorized to say what they are, but yeah, we're working on some stuff, hoping to grow a little bit. But I mean, mostly what I want to do is stick around and help people, and support the product that I believe in.
Yeah, and one thing I do like about your guys' product, and this is kind of off of those topics, there is, for the guy installing the first time, there aren't 1,000 modules behind the scenes to make it work. It's really just the panel and like you could literally get by with an EIS and a mini just going power ground and communicating, and you've got a VFR plant panel.
Yeah, we try to contain as much as possible inside the unit itself. And I mean, what 10, 20, 20 about 20 years. My point being, our older screens actually had an external AHRS because the circuitry was too big to fit inside the unit. But technology moves on, things get smaller, everything's small enough we can fit it right in there. And our philosophy is, why not just add as much as we possibly can to that unit to make it better?
Well, I said, great to hear that you guys are always innovating, trying to find better ways to do it. And if they want to check you out, obviously grtavionics.com. And
Mm-hmm.
we'll definitely be doing one of these in the future, maybe on troubleshooting or again other things that are how to use the panel. So great talking to you, John. And
You
for
as
those of you
well.
guys out there, see you next time.